Alright, now we will look at the fifth type of the particular integral. So we know that the particular integral yp will be given by phi of x divided by f of d. In this case, we will see that the type 5 includes a specific type of this. The phi of x will look like x into v, right, where v is a function of x. So previously we had seen that e to the ax into v was type 4. Now this is type 5. So the solution is like this. If at all we have the yp is equal to x into v over f of d, this is given by x minus f dash of d divided by f of d, this whole thing into v over f of d. This is like a formula which we need to follow whenever we encounter the fifth type of differential equation. All right, so let's go with an example first. Let us see an example, then we'll proceed. So let's say in a problem we got yp is equal to x cos x divided by d square plus 9, right? So we can see that x into v, so the v becomes is equal to cos x, right? F of d is equal to, so let's write down what we observe from this. We need to compare this with x into v divided by f of d. So v becomes equal to cos x, f of d becomes equal to d square plus 9. All right, so we know that the yp becomes equal to, therefore yp, let's write the equation once. This is x minus f dash of d by f of d multiplied by the v, in this case I'll write the v as it is. Okay, let me write the equation once, then we can substitute, right? This is f of d, so we need f dash of d as well. So let me write f dash of d is 2d. So we use all of them together to substitute like this. So this is x minus f dash of d will be 2d divided by f of d is d square plus 9 is the inside the bracket into, this is cos x divided by d square plus 9. Okay, so now I understand one thing from this, that is this a particular term is actually a type 2 function. So replace d square by minus a square. So that means I should replace d square by minus 1, because cos ax, a is equal to 1 in this case. I should replace the d square by minus of 1 square, that's minus 1. So this is equal to x minus 2d over d square plus 9 into cos x by -1 plus 9 is 8. All right, now this term should be multiplied to the terms containing inside the bracket. So I'll take the 1 by 8 outside. So this becomes x cos x minus 2 times differentiation of cos x by d square plus 9. So this means this is equal to 1 by 8 into x cos x plus 2 times differentiation of cos x should be minus sin x. That's why that has been taken care by writing a plus over here. So 2 times, this is sin x divided by, anyway, I know that d square should be replaced as -1 here, so this becomes 8. So this cancels with this as 4. All right. So we have this term equal to, I can take the 8 inside now. So this is x cos x by 8 plus sin x divided by 32 will be the yp for this problem. All right, now we'll go to the solution of complete differential equation. Let's say equation given is y double dash plus 16 times y is equal to x sine 3x. So we get d square plus 16 into y is equal to x sine 3x. So our first objective is to find yc, the complementary solution. For that we need to write the auxiliary equation, that is replacing capital D by m. I get m squared plus 16 should be equal to 0. So m become equal to root of minus 16. So my root of -1 is j, and there are two roots, plus or minus j4. So we understand that the roots are purely imaginary and they are conjugate pairs. So this implies the yc is equal to, there is no real term, so e to the power 0, it's 1, then a constant into cos 4x plus another constant c2 into sine 4x. All right, so we got a yc now. Our next intention is to find yp. Right. So how to solve this? This can be solved easily by looking at the equation, that is yp is given by phi of x over f of d. So in this particular case, we observe that the phi of x is x into sine 3x whole divided by, this is d square plus 16 All right, so this I observe that this is x into v over f of d. So where v is sine 3x, f of d is equal to d square plus 16. So we need f dash of d, that is 2d. So type 5, as soon as we observe type 5, the yp is now, you can calculate using the formula, that is x minus f dash d by f of d into, this is v over f of d. So we know the values to be substituted. We'll simply substitute that. That is x minus 2d over f of d is d square plus 16 into, what is v? V is equal to sine 3x divided by d square plus 16. So this is type 2. So replace d square by minus of a square. So minus 3 square. 3 square is 9. So minus 9. All right. So this is equal to x minus 2 times differentiation 2d by d square plus 16 into, this is sine 3x divided by, this is minus 9 plus 16. So this becomes equal to 7. So in the next step, we will, I'll take the 7 outside, 1 by 7 into, this is x into sine of 3x minus 2 times differentiation of sine of 3x whole divided by the d square plus 16. So again, we'll simplify this as 1 by 7 into, this is x into sine 3x minus 2 into differentiation of sine 3x is 3 cos 3x by d square plus 16. Now substitution is d square by minus 9. 1 by 7 into, this is x sine 3x minus 2 into 3 is 6. This is cos 3x whole divided by 16 minus 9 is once again 7. So what we can do, we can take the 7 outside once. This becomes 1 by 49 into, this is 7 times x into sine 3x minus 6 times cos 3x is the yp. So to write the final answer, that is y is equal to yc plus yp. So substituting from the yc and yp we obtained so far, this is c1 into cos 4x plus c2 into sin 4x plus 1 over 49 times, we copy this from the yp value we obtained just now. So that is 1 by 49 into, this is 7 times x sine 3x minus 6 times cos 3x is the final answer. All right, then the next problem is like this. This is y double dash minus 2y dash is equal to x into cos x. This is d squared minus 2d plus 1 into y is x into cos x. To find yc, we'll write the auxiliary equation as m squared minus 2m plus 1 equal to 0. This is m minus 1 the whole square equal to 0. So we observe that m becomes equal to 1 comma 1, which means roots are real and repeated. So when we have the roots in the real and repeated format, the yc is guessed as c0 plus c1 into x into e to the power the root into x. So the root is 1, so this is x. Okay, let's call this equation as equation number 1. Then we need to find the yp. To find yp, the yp is equal to the phi of x given in the equation divided by f of d. So in this case, we observe that the yp is equal, this is x into cos x whole divided by f of d is nothing but d square minus 2d plus 1. Okay, so now we observe that the v is equal to cos x, f of d is equal to d square minus 2d plus 1, and we have f dash of d is 2d minus 2, which can be written as 2 times d minus 1. So we note that this given problem has the numerator of the yp which belongs to the type 5. So I write the equation x minus f dash of d divided by f of d into the v divided by f of d. So we'll substitute. This is equal to x minus f dash of d is 2 times d minus 1 divided by f of d, which is d square minus 2d plus 1 into the v, that is cos x divided by, this is d square minus 2d plus 1. So we note that the rightmost term is in the type 2. So we replace d square by minus of 1 square, which is minus 1. So this becomes equal to x minus 2 times d minus 1. So look at the denominator. This is actually a perfect square. So d minus 1 the whole square. I'll write this because I can cancel one of them. Okay, into this is cos x whole divided by this is minus 1 minus 2d plus 1. So this plus 1 minus 1 cancels. There is only minus 2d left. So I know that d coming into denominator I have, so I need to simplify that further. So what I do, I'll take the term like this. I'll keep it minus 1 by 2 outside. There is x minus 2 over d minus 1 into, so this is cos x. I have a d in the denominator. To make it d square, I multiply and divide by d. All right, so what happens? This is minus half into this is x minus 2 over this is d minus 1 d of cos x. So this is nothing but differentiation of cos x. So differentiation of cos x is minus sin x whole divided by, there is a d square. So what I am supposed to do, replace d square by minus 1. So this is minus 1 by 2. This is x minus 2 over d minus 1 into this is minus of sin x by minus 1. The minus minus will cancel. All right. So in the next step, now I have to multiply the sin x to every term that is present inside. So that is minus 1 by 2 into, see, this is x into sin x, then minus 2 times sin x divided by this is d minus 1. So d minus 1 is in the denominator. I need to have a d square, so I multiply and divide by d plus 1. Because since the numerator has a sin x, only when I have d square I can make a substitution. Okay, so this is minus 1 by 2 into x sin x minus, now multiply to d, so this is minus 2d sin x, and another term is minus 2 times sin x. So whole divided by this is d square minus 1. So replacing d square by minus 1, because d square is minus a square, a is 1, right? So this is minus 1 by 2 into this is x sin x minus 2 times differentiation of sin x is cos x. So 2 cos x minus 2 sin x whole divided by this is d square is minus 1, so minus 1 is minus 2. So this minus 2, this minus 2, this minus 2 will cancel, everything will become positive. So the final answer I'm going to write as minus half into this is x sin x plus cos x plus sin x. Okay, that can be further reduced into this format. So I'll take sin x outside, so that becomes x plus 1 into sin x plus cos x. All right, so this is the y P. So we already have the YC with us. Therefore, we write the final answer. Y is equal to YC plus YP. So YC, we obtained C naught plus C1x into e to the x minus 1 by 2 times. This is x plus 1 into sin x plus cos x. This is the final answer. All right, let's proceed further to solve another question. Okay, this is the question. Y double dash minus 2y dash plus y is equal to x into e to the x sin x. So we can rewrite this as d square minus 2d plus 1 times y is equal to x into e to the x sin x. First we need to find yc complementary solution. So we go for the auxiliary equation, replacing d square d by m. D square becomes m square minus 2m plus 1. This is equal to 0. This left hand side is a perfect square, so we know that this is m minus 1 the whole square equal to 0. That gives m equal to 1 and 1. Roots are real and repeated, that's why we guess the yc is equal to c naught plus c1x. Since two roots, we write two terms into e to the power that root, which is 1 into x. Call this as yc, equation number 1. So our next step is to find yp. So how do you find yp? You write the standard equation. Yp is the phi of x divided by f of d. So when I want to do the phi of x by f of d, I need to check what is the phi of x. Therefore, the yp is equal to, in this case, this is e to the x into, I'll write it in this fashion, e to the x into x sin x whole divided by, this is d square minus 2d plus 1. So first I make a note that this is e to the power ax into v format, because this, I can see that there is a type 4 first. So what type 4 suggests, replace every d by d plus a, that is e to the power whatever content it is. So e to the power 1x is there, so d plus 1. This will be my first step. All right, so that is e to the x. I keep e to the x aside. Now I come back to x into sin x divided by, so see, this is d plus 1 the whole square minus 2 times d plus 1 plus 1. So after I simplify this, then I go for x sin x. All right, so this means now I can rewrite this as this is e to the x into x sine x whole divided by, expand the d plus 1 whole square, which is d square plus 2d plus 1 minus 2d minus 1 and plus 1. So I can see that minus 2d plus 2d cancels, plus 1 and minus 1 also cancels. All right, now this is equal to e to the x into, this is x sine x divided by d square minus 1. So now this is in the type 5. What I'm going to do, I'm going to write the first, let's keep the e to the x as it is, e to the x into, see, this is x minus f dash of d by f of d into, this is v over f of d. So if you note it down, the f of d is d square minus 1 and v is equal to sine x. F dash of d is 2d. So that's why this is e to the x into, this is x minus 2d over d square minus 1 into, this is sine x over d square minus 1. So replace d square by minus of 1 square, which is minus 1. So what happens now? E to the x into, this is x minus 2d over d square minus 1. This is sine x over minus 1 minus 1. So that is minus 2. So this means it is equal to e to the x into, the minus 2 I'll take it out. Minus 2, it goes out. Now let's multiply the sine x to the bracket. X into sine x, x into sine x minus 2 times differentiation of sine x divided by d square minus 1. So I need to make sure that d square gets replaced as minus 1 itself. So this is minus of e to the x by 2 into, this is x sine x minus 2 times differentiation of sine x is cos x and denominator is minus 2. Minus 2 and minus 2 cancels. This becomes plus. This is sine x. Right? So this is the yp. All right. Now to write the final answer, we need y is equal to yc plus yp. So this is equal to yc, we already have calculated, that is c naught plus c1x into e to the x. Now this is minus e to the x by 2 into, this is x sine x plus sine x, x plus 1 into sine x, that's all. I think we made a mistake here. Yeah, sorry for the inconvenience. Please correct, that is 2 times differentiation of sine x should be, this is cos x, right? Kindly correct. So this is cos x. So we have cos x over here. This is the final answer. All right. So all the 5 types of problems which can come right as a question paper problem, we have solved in the linear constant coefficient differential equation. Thanks for watching.